Okay, welcome back everybody. I've got an important announcement to make here. We're going to skip Unit 4, Chapter 5, Simplifying Complex Rational Expressions, and move on to Unit 4, Chapter 6, Solving Rational Equations. Now, it's my understanding we're just not going to include Unit 4, Chapter 5 in the curriculum this semester since we're behind schedule. So, but if I hear otherwise, I'll obviously make some videos and we'll try to get that done as well. Okay, so let's begin. We're going to look at solving rational equations. All right, now, first things first, let's just take a quick look at a property of the real numbers. And now it just says that if A over C equals B over C, then it must be true that A equals B. And this is just another way of restating that if I were to multiply both sides by C, like so, the denominators would cancel out, and we'd just be left with A equals B. Okay, now let's do a quick review of something we covered in Unit 2, and that's solving fractional linear equations. Okay, so let's solve the following fractional linear equation. And we've got 2x over 3 minus x plus 1 over 6 equals 3 over 2. Okay, well, I suppose the first thing we should probably do here is build a common denominator. So we'll just quickly state that the least common denominator here is equal to 6. And so we need to build up these fractions. Okay, the idea here is we want all the denominators to be the same so we can cancel them out. Right, we're trying to clear the denominators here. All right, so if this one has a 3 as a denominator, then we should probably multiply it by 2 over 2. I hope you agree with that. Okay, so I'm going to multiply that first one by 2 over 2. Okay, now this one already has the least common denominator, so we can just leave it as is. And this one needs to be multiplied by 3 over 3 to get the common denominator. Okay, so let's just polish this up really quickly. Well, what do we get? We get 2 times 2x is 4x over 2 times 3 is 6 minus x plus 1 over 6 equals 3 times 3 is 9 over 6, like so. Okay, and now we can form a single fraction on the left-hand side. Since we have the common denominator, just remember we're going to need to distribute the minus sign because we're subtracting this whole thing here. Okay, now this is all over 6. And the right-hand side hasn't changed at all. We still have 9 over 6. Okay, now at this point, we're just going to maybe simplify the numerator here a bit more. I'm just going to distribute the negative sign. So I get 4x minus x is 3x. And then we distribute the negative to the 1 as well, which just gives us 3x minus 1 over 6. And now we can multiply both sides by 6, or use that property we stated right at the beginning to cancel the denominators. I think you'd see most people just say, let's multiply that side by 6, multiply that side by 6. like so. And that just leaves us with a linear equation, 3x minus 1 equals 9. And now to solve this, you just add 1 to that side. And we're just trying to isolate x here. And then divide by 3. And that's our solution. X equals 10 over 3. Just as a quick reminder, this is a conditional solution. We're getting exactly one solution, so we're going to call it a conditional solution. Okay, good. Let's carry on here. I'm just going to start a new page. All right, so let's look at another property here. I think I'm going to call this property star, so that you guys know when I'm using it. It's called property star. Property star. And it just says if a over b equals 0, then it must be true that a equals 0. Okay. All right, so what's the idea here? Well, again, it's just simply saying that, yeah, you know what? We could just multiply both sides by b, and the b would cancel there. And then, of course, 0 times b is b. Okay, so what we're going to do is we're going to use this to clear our denominators when we're solving rational equations. Okay, so let's talk about how to solve rational equations. To solve, I'll just put to solve here. I think we're all feeling pressed for time at this point, aren't we? We're going to set the equation equal to 0, which just means we're going to move everything to one side. And then 2, we're going to factor the denominators. To find the LCD. And build up the fractions. We're going to clear the denominators using the above property. 4, we're going to solve the resulting equation. And that means we need to be able to identify what type of equation it is, right? We haven't run into too many equations yet, but you know, when you're doing this, you could end up with a linear equation. In other words, the highest power of x will be 1. You could end up with a quadratic equation. In other words, the highest power of x is x squared, or you could end up with a higher degree polynomial equation. And the last thing we're going to do is look for extraneous roots. And I'll explain what that means once we extraneous roots. And I'll explain what that means once we come upon it. Okay, so the first thing I'm going to do here is I'm going to do the oh no, actually never mind, I've got an example all worked out for you here. At one point I'm going to get you guys to do try to pause the video, but we're not going to do that yet. Okay, so let's do this example. let's solve x over x minus 5 plus 3 over x plus 2 equals 7x over x squared minus 3x minus 10. Okay, well, I mean, there are two approaches here, but again, I'm just going to stick with this approach that I've set up for you here. And essentially the idea is this. I'm going to move everything to the left-hand side so that I can apply this property. I'm going to set it equal to 0, and then just clear the denominators. Okay, so what you'll see here is if you can just add and subtract rational expressions, what we did in the last lecture, then you should be fine here. Okay, so the first thing I'm going to do is I'm going to subtract this whole thing to the other side. So what does that look like? Well, I'm just going to do this. I've got x over x minus 5 plus 3 over x plus 2, and then I'm going to minus that to this whole side. I always tell my students, why not? Why can't we do that? It's just apples and oranges here, right? I've got an apple here, I'm going to eat it. I'm going to subtract it to the other side. Minus 7x over x squared minus 3x minus 10 equals 0, right? If I subtract this from that side, it just goes away completely. Okay, next, we need to build up our fractions here. We need to make a common denominator. So we need to factor this one here. And, you know, these questions, if you look at the other factors, it's usually a pretty good guess of, it's a pretty good indication of what the factorization is, because otherwise the questions are going to get really messy. But we should be sure and just factor this properly. Okay, now this is one of the easier types where we can just do it by inspection. And again, if you like to do these by decomposition, then by all means do that on your own at home. But I can see that minus 5 times 2 multiplies to minus 10 and adds to minus 3. Therefore, the factorization of this is x minus 5 times x plus 2. Okay, so again, the factorization of this is x minus 5 times x plus 2. And this all equals 0. Don't lose that right-hand side here. Okay, now we can state the least common denominator. Our LCD here is just x minus 5 times x plus 2. Right, we need the denominators to match before we start adding the numerators together. And you can see pretty easily that, well, if I just multiply the top and bottom of this by x plus 2 and the top and bottom of this by x minus 5, they'll all have the same denominators. Okay, so I'm going to move to a new page here. So let's start building up the fractions. Okay, so again, I need to multiply that first fraction by x plus 2 over x plus 2. And this fraction I need to multiply by x minus 5 over x minus 5. And then we don't have to do anything to the last fraction. All we need to do here is make sure we don't run out of room. And we just managed to squeeze that in. Okay. Now the next thing we're going to do is just form a single fraction. And this is just like what we did in the last video. We're just building this into a single fraction. And again, I know my LCD is x minus 5 times x plus 2. So instead of writing that over and over, I'm just going to do this. I'm going to use that for my LCD. And then I've got x times x plus 2 from this one, plus 3 times x minus 5 from that one. And then we've got minus 7x equals 0. And I think from here, you could honestly clear the denominators here if you wanted, but I think at this point I'd probably just clean this up a bit. So I'm going to distribute and collect like terms. That was from distributing that x there. And then I need to distribute the 3. So I get plus 3x minus 15. And then I need to subtract 7x. All right, now if we collect our like terms, we're just left with x squared, 2x plus 3x is 5x, minus 7x is minus 2x. And then we've got minus 15. This is all over LCD. Equals 0. And again, now I can just cancel out the common denominator here. Okay, we've got a couple factors down here. I could just multiply them to that side, or just apply that property that we said, a over b equals 0. Well, that implies b equals 0. Yeah, so we can just get rid of the denominator here. And that leaves us with this, x squared minus 2x minus 15 equals 0. And at this point, we've got a quadratic equation left over. We just need to solve it and then check our answers back in the original equation. And so if I factor this, what do I get? Well, minus 5 plus 3 adds to minus 2. Excuse me. So therefore, we're looking here, sorry, because I sneezed, let's repeat this. So I'm looking for something that multiplies to minus 15 and adds to minus 2, which is minus 5 and plus 3. Therefore, the factorization of this is just x minus 5 times x plus 3. And again, do the decomposition at home if you wish. Okay, now applying the zero product property, we can see that x equals 5 is a solution. Okay, we don't know that it's a solution yet, but we're solving this equation here. It's not the same as looking for domain restrictions. And this one gives me x equals minus 3. Okay, so essentially what you need to do now is we need to check for extraneous solutions. Well, what is an extraneous solution? Essentially, if one of your answers doesn't work in the original equation, then that means it's an extraneous solution. Okay, and in this case, the x equals 5 is an extraneous solution because of this. If we go back a few steps here, look what happens if I put in x equals 5 here. I get 5 minus 5 is 0. That's division by 0. That's not allowed. Okay, so this x equals 5, we would say this is an extraneous root. Okay, whereas this x equals minus 3, this is a valid solution. It's not going to give us division by 0 anywhere. Okay, so let's see. Wow, we're at the 20-minute mark here, so I'm going to buzz through another example. But if you want to pause the video here and try this question before I do it, what I'm going to do next is the U-try on page 313. Okay, so take a moment to try to solve the question, and then this will help you. If you make a mistake, it'll help you learn what mistake you're making and hopefully not make it again. Okay, so again, this is page 313. And we're asked to solve x over x squared minus 9 plus 4 over x plus 3 equals 3 over x squared minus 9. Okay, so first things first, set it equal to 0. We're just going to move this to the other side by subtracting it over. Now minus that whole thing over here. Like so. Okay, now factor the denominators. We've got a difference of squares, difference of squares. So we can factor this as so. X minus 3 times x plus 3. This denominator is already factored, plus 4 over x plus 3 minus 3 over x minus 3, x plus 3. And this equals 0. Okay, now you can see our LCD is just x minus 3, x plus 3. Sorry, I'm going pretty fast here. I wanna get through this video, or get this video done in under half an hour. So, okay, so we just need to build up this fraction at this point. I need to multiply the top and bottom of it by, yep, you guessed it, x minus 3 over x minus 3. And this one can be left alone. It's already got the common denominator. And this all equals 0. Okay, so let's simplify. Again, I'm just going to write the LCD in the denominator to indicate that that's what's there, so I don't have to write it a bunch of times. And I've got x plus 4 times x minus 3 minus 3 equals 0. And we're just going to distribute and collect like terms. And that gives me 4 times x is 4x, plus x is 5x. And then I have 4 times minus 3 is minus 12. Minus another 3 is minus 15. And isn't that nice? We've cleaned this up quite a bit. Okay, now at this point, again, we have something over something equals 0. Therefore, the numerator must equal 0. We'll just cancel out the denominator. Okay, and now, what are we left with? We're left with 5x minus 15 equals 0. And as I said, you could be left with different types of equations here. This one happens to be a linear equation, which we just solve by isolating x. So plus 15 and then divide by 5. And that gives me x equals 3. Okay, right about now you're saying, but wait a minute, Mike. Geez, just occurred to me, did I mention my name is Mike? Well, hi guys, I'm Mike. Okay, so right about now you're going to say to me, wait a minute, Mike. This is one of the zeros for the denominator. Look, our LCD is x minus 3 times x plus 3, but if I put x equals 3, and I'm going to get division by 0. Therefore, we've got an extraneous root here. So what does that tell you? Well, we've solved the equation. We found one value of x. It's extraneous, and there are no other values of x. Therefore, this equation has no solution. Or we have no solutions. Good. Okay, that's it for now. I'm going to probably do one more example from the textbook here, but not tonight. It's getting late here. It's been a busy day, as I expect it's been for everybody. So I'll upload that tomorrow. See you then.